So 7.3 equation of straight line. So you should already know that the equation of straight line is y equal to mx plus c, where m is the gradient and the c is the y-intercept. So there is an alternative formula that can be used when you know the gradient of the straight line and a point on the line. Consider a line with gradient m, which pass through the known point, okay, x1, y1, and whose general point P is the xy. Okay, so we know that the gradient is m. So the gradient of PA is m. The gradient of PA is what? Y minus y1 over x minus x1 equal to m. So we have the y minus y1 equal to m x minus x1. Okay, so this the equation for the straight line when we know the gradient is m, which pass through the point x1, y1 is the y minus y1 equal to m x minus x1. So we look at the work example number 7. Find the equation of straight line with the gradient 2 pass through the point 4, 7. So we have the gradient equal to 2 and it passed through 4, 7. So we have two methods to solve it. The first method is what we learned in the MM. So we have the y equal to 2x plus c. So when x equal to 4, y equal to 7, then 7 is 2, 4 plus c. So c is 7 minus 8, then is equal to negative 1. So the y is 2x minus 1. So for the mx here, we have the formula y minus y1 equal to mx minus x1. So we have the y minus 7 equal to the m, that is 2, x minus 4. So we have the 2x minus 8 plus 7. So the y is 2x minus 1. So the answer are the same, but this one is faster. So the MX method is faster. Okay, so we continue with B. So find the equation of straight line pass through point, these 2 points. Okay, so for this one, we can find the gradient. So the gradient is negative 4 minus 8 over 1 minus negative 5. So it's negative 12 over 6, negative 2. Okay, so we can use either point, but I will use the smallest one. So we have the mathematic way y equal to negative x plus c. So we have the negative 4, negative 2, 1 plus c. C is negative 4 plus 2, negative 2. So y is negative 2x minus 2. Or we use the mx method. We have the y minus negative 4 equal to negative 2x minus 1. So we have the y equal to negative 2x plus 2 minus 4. So equal to negative 2x minus 2. Okay, or we use the other point. So y minus 8 equal to negative 2x minus negative 5. So we have the negative 2x plus 5 multiply then minus 10 plus 8. So the y is negative 2x minus 2. Yes, okay. But actually for this kind of problem, we have the other method. Okay, we have one more method to solve this kind of problem. So for this kind of question, we have method number 3. That is, we have the y minus negative 4 over x minus 1 equal to the 8 minus negative 4 over uh, not 8 minus negative 4. So we have the negative 4. So we have the negative 4 minus 8 over 1 minus negative 5. Okay, so we have the y plus 4 equal to negative 12 over 6 x minus 1. Okay, so this one negative 2, and then we multiply in, then we have the y equal to 2 negative 2x plus 2 minus 4. So y equal to negative 2x minus 2. So actually we have another formula, which is the y minus y1 over x minus x1 equal to y2 minus y1 over x2 minus x1. If we have x1, y1 and the x2, y2 is provided. Okay, so we have two coordinates and then we want to find the equation, we can use this formula. Okay, so if we have this one is we have the m and x1 y1. Okay, so this one the gradient, the model max method, we also have the m is and 1 point. If we have 2 points, then we can use this method. This is faster. Okay, we'll look at the question book example A. We need to find the equation of perpendicular bisector of AB. So perpendicular bisector of AB. So we have the AB here. Let's say we have the AB here. So perpendicular bisector, that means it is perpendicular to AB and then pass through the midpoint of AB. Then that is the perpendicular bisector of AB. Okay, so this one we have the first. So to find the perpendicular bisector, okay, we need to find the midpoint first. So the midpoint is 3 plus 7 divided by 2, 2 plus 10 divided by 2. So the midpoint is 5, 6. Okay, so 10 over 2, 5. 12 over 2, 6. And then the gradient of AB will be 10 minus 2 over 7 minus 3. So 8 over 4. So it's 2. So the gradient times the gradient of AB is equal to negative 1. When it is perpendicular, then they will become negative 1. So gradient is negative 1 over gradient of AB. Then there will be the negative 1 over 2. Okay, so now we know that the gradient is negative 1 over 2 and it's passed through the point 5, 6. So to find the equation, it will become y minus 6 equal to negative 1 over 2 x minus 5. Okay, then we have the negative 1 over 2 x plus 5 over 2 plus 6. So y equal to negative 1 over 2 x plus 12, 17 over 2. So 5 over 2 plus 6, 17 over 2. Yes. Okay. So we check with the decimals. So we have the 3, 2, and then we have the 7, 10, and we have the 5, 6, and we have the y equal to negative half x plus 17 over 2. Okay, so we have these 3 points. So this is the graph. This is how the graph look like. Okay, so this one is the perpendicular bisector. So we know that we have this 3, 2, 3, 2 is A. So this is A, this is B, this is the midpoint, then it's perpendicular and cut it into half, perpendicular bisector. So this is the perpendicular bisector of AB. Okay, so for this one, we have the 5 over 2 plus 6 is 17 over 2. So if we want to do it manually, then the denominator is 1. So we change to have the same denominator. So we have the 12 plus 7, 17. 12 plus 5, 17. 17 over 2. Okay. Hmm. So just now this one we move to this side. This one we multiply in. Okay.